Alright, so this should say 8.2 by the way, sorry. So 8.2, arithmetic sequences and partial sums. The definition of a sequence here, an arithmetic sequence, here's a simple everyday language on the top. So a sequence whose consecutive terms have a common difference is called arithmetic. That's as simple as I can introduce it for you to understand. Here's the actual definition, the mathematical definition, and obviously always those are wordy and get a little confusing, but this one's not too bad. It says, a sequence is arithmetic if the difference between consecutive terms are the same. I understand that. So the sequence a sub 1, a sub 2, a sub 3, a sub 4, dot, 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 a sub n is arithmetic if there is a number d such that a sub 2 minus a sub 1 is equal to a sub 3 minus a sub 2, which is equal to, I don't know, I can do this, a sub 4 minus a sub 3, a sub 17 minus a sub 16. You guys see how it's always one term minus the previous one? It's going to give you the common difference. Try it on the ones that I have on the board. 2 minus 1, 1. 5 minus 4, 1. 8 minus 6, 2. 6 minus 4, 2. You guys see how it's staying constant? It doesn't matter where you try it on the sequence, you're going to have a constant difference. Okay? The number d is known as a common difference. And to find the difference anywhere, it's just like what I just told you. Just pick two numbers that are consecutive and subtract them. Okay? This formula you're going to have to memorize. The nth term of an arithmetic sequence can be found using this formula. That means that if I ask you, hey, can you tell me what the 100th term of this sequence is? All you got to do is plug in 100 into the formula, as long as you have all these other unknowns, right? So to find any term, first of all, you need to know the first term. Okay? N will represent what? Whichever term you're trying to find. And D represents the common difference. Cool? So we're going to start with very basic, very simple ones. So example number formula for the nth term of an arithmetic. Notice how I'm telling you. It is arithmetic. Yes? Cool. I am literally telling you in the instructions. It is arithmetic. If I don't tell you it's arithmetic, you cannot assume that. Okay? Whose common difference is 5 and whose first term is negative 1. So here's what I know. A sub 1 is negative 1. D is 5. As long as you know this formula, you're good to go. So what is a sub n? Well, a sub n is equal to the first term, which is negative 1, plus n minus 1 times the common difference, which in this case is 5. I will expect you to go further than this since you're pretty P. Reduce. So a sub n would be equal to what if you reduce? So 5n minus 6. And we're done. Cool? Try number 2 on your own. And number 3, turn it red on your cups. And when you're done, turn to green, please. Alright, if you're watching the video, go ahead and check your answers. And moving on. Alright, this time it's going to get a little bit more difficult, but it's not going to be terrible. So let's look what they have given us. It says, write the terms of the arithmetic sequence. The fourth term of an arithmetic sequence, notice that you are told that it is arithmetic. The fourth term is 20, so here's what I know. A sub 4 is 20. The 13th term is 65, so a sub 13 equals to 65. Write the first 5 terms of the sequence. Okay. Well, the thing we got going on for ourselves is that the fact that it's arithmetic, that's going to help us out a lot. So I'm going to do this problem the long way first so that I can show you how you can kind of do this problem faster. But here's what, like, let's pretend this is the first time I've ever doing this. I'm like, okay, hold on, wait a second. So I know that this is the fourth term and it's 20, right? Then after that I'm going to have a 5th, a 6th, a 7th, an 8th, 9, 10, 11, 12. And finally I'm going to have my 13th term, right? You guys follow me? So I'm like, okay. So in between here, there's 1, 2, 3, 4, 5, 6, 7, 8 numbers, right? But what I remember from arithmetic is that to get from here to here, I would add the same number. And to get from here to here, I would add the same number. Add the same number. Right? So let me look at this, okay? I'm going to turn this, I guess, drawing or sketch into an actual equation. Well, you're telling me then that if I have 20 and I add D, and then I add D, and I add D, and well, can I just combine all these differences? How many do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I do 20 plus 9D, what are you going to get? 65. You guys with me? So then from there, 65 minus 20 is 45, and 45 divided by 9 is 5. So D is equal to 5. Look at that. You guys with me? Alright, so I have the D is 5, and I know that the formula says that A sub n equals to A sub 1 plus n minus 1 times D, right? So what's the last thing I need in order to figure out this? The first term. Well, by now, it really depends on what you want to do. This was the fourth term, so you can just literally subtract 5 and get to the first term like that. But there's got to be an algebraic way to do this, right? Just in case, because just so you know, I mean, we started with something simple. I'm probably going to give you like ace of 50 is this and ace of 100 is this, so that you won't try to go 50 times back to the first one. So algebraically, how would I attempt to do this? Any thoughts? What's that? Is there any way that you can use what was given to you here?
What I did, I made a ratio from the fourth term of that 20th. The answer was a fifth, and the search was 55, so it was 1/5, and I just solved for manually.
Okay, I like that. Hey, that works. I'm cool with that. Totally. Okay, that's where I'm going to go with the shortcut here in just a second. Good. I'm going to go, that's going to be the shortcut that I'm going to show you here in just a second. So fantastic. You figure it out on your own. But let's see, at this point, let's say, like, this is the very first time I'm doing this. I'm just like, I'm not really quite sure. There's got to be an algebraic way, and they're giving me this information, and I know this. Is there any way that I can use this information and this to figure out what ace of 1 is? Let's plug in numbers. Alright, let's start with, do we know what D is now? Okay, so we know we just found that it was 5, right? So we know 5. Okay, this is not going to change, right? This is what we're looking for, so I'm going to leave it there, right? So then I'm looking at this. I have ace of n and I have n. And I have this information that was provided to me. Well, ace of n can represent any number on the sequence, right? So could I just plug in, I don't know, 20? But if I plug in 20, then what's n? 4. And do you guys see now how I have one unknown? Which is what I'm looking for. Okay, what's 4 minus 1? Times 5. So minus 15. So what's ace of 1? Alright, this got a little messy, but what's my final answer? Well, ace of n is equal to what? 5 plus n minus 1 times the common difference, which is 5, right? I'm going to simplify this out. 5n minus 0. Okay, 5n. Right? That took a lot of thinking, right? Like, that was just too much work. We can save a lot of work, but I want to make sure you understood where everything came from, okay? All right, I'm going to share with you, like, an unofficial formula, okay? This is not an actual formula, but here's what I do. I want you to notice how when I came here, when I set this up, it eventually became 65 minus 20, right? And then we divide it by 9. Well, if you notice from the beginning, you could have just done that ratio without having to set all this up. You could have said, well, this is the last term, this is the first term that I have, right? Or in between. If I subtract those, I'm going to get the difference between it, right? But all the terms in between should have the common difference, so if I just divide it by the number of terms there is in between, I should be able to get my common difference. Because there is 9 terms, 45 divided by 9 is 5. So the unofficial formula would be last term given minus first term given all over last nth term minus first nth term. Do you guys see how that's just done? It's not a formula, it's just like kind of unofficial. So it's like the actual value, so 65 minus 20 minus the term. This term was 13, right? And this term was 4. 13 minus 4 is 9. Do you guys see how that's the amount of spaces or numbers or terms that figure out your first term? You can try this. There's several ways. I'm not going to force you to do any one specific way. I'm going to let you figure this out. This is the one that I showed you because I guarantee you will get the correct answer. If you can reason something out like the ratio, fantastic. If you want to figure out your own type of formula, fantastic. I don't mind. Okay? So, number 5, number 6, number 7, go for it. Number 5. So, I know that the 8th term, so ace of 8 equals to 25, and ace of 12 equals to 41. So to find the common difference, I'm going to do 41 minus 25 over 12 minus 8. Right? So then 41 minus 25 is 16, and 12 minus 8 is 4. Therefore, the common difference is 4. Okay. Once I have the common difference, I'm going to use the formula ace of n equals ace of 1 plus n minus 1 times d to figure out the first term, and I'm good to go. Okay? So I'm going to plug in. I typically like to pick the lower values to keep the math simple. So I'm going to say 25 is equal to ace of 1 plus, well, 25 was the 8th term, so that means I'm going to plug in 8 there. So 8 minus 1 is 7 times d, which is 4, right? So then what's 7 times 4? 28. And 25 minus 28 is negative 3. That means that the first term is negative 3. And that means that ace of n is equal to negative 3 plus n minus 1 times 4. Agreed? I'm doing a little bit more than what they asked just so that I practice the skills here, right? Because what did they ask for? Just the first 5 terms, right? They didn't really ask me for this, but it doesn't hurt to have it, right? So then ace of n would be equal to 4n minus 7. Agreed? But what are the first 5 terms? Well, I know that the first term is negative 3. And what's the common difference? 4. So what's the next one? 1, 5, 9, 13. And I'm done. Cool? Alright. This one's a little bit different. It says find the 10th term of an arithmetic sequence. Again, it was given to you, that begins with 8 and 20. So that means this is 8, comma 20, comma something else, right? So this one actually turns out to be very simple because they're consecutive. So now you know automatically that the common difference is 12. And that the first term is 8. Right? Okay. Ace of n equals to 8 plus n minus 1 times 12. Ace of n equals to 8 plus 12n minus 12, right? So ace of n is equal to what? 4. So why did I figure this out? Because it's a lot faster to plug in 10 than try to add 12 until I get to 10, right? So then ace of 10 is equal to 12 times 10 minus 4. Ace of 10 is equal to what? 116. Cool? Yes, ma'am. Oh, absolutely not. Yeah, no. Yes.
When it just says 8 plus n minus 1 times 4, can you just plug in 10 right there?
Right here? Yes. So that's what I did right here. So, or yeah, you don't have to do all this. So like, if you're right here, you're too lazy to go up here, like that's fine. I'm lazy too. I'll just plug in 10 right there and get it over with. Cool? Because they didn't ask me for the formula. I found it just to get the answer, right? Cool? Alright, number 7, it's actually relatively simple. It all has to do with vocabulary, so I just want to make sure that you understand what this means because this will be on the test. Write a sequence that has 2 arithmetic means in between these 2 numbers. Notice that they don't tell you what term this is. They don't tell you if this is the first, the 10th, or whatever. But since they told you it's arithmetic, make it the first one. Why not? So the first one's -5. Having 2 arithmetic means in between those 2 numbers means that you have 2 numbers and then 4. So then, how would we figure this out? Well, if I made a sub 1 -5 to make the problem easy, that means that a sub 4 is 4, right? So, how can I figure out the common difference? 4 minus -5, right? This is the 4th term, so 4 minus the first term. So notice it's the same thing I did for number 5, right? So what's 4 minus -5? 9 divided by 3, so that's 3. Okay, so that means that the common difference is 3. So if the common difference is 3, what will be this number? -2 will be this number. And it matches, right? So what are they asking us for? They want the actual sequence, right? So a sub n, do you have the first term? -5 plus n minus 1 times, do you have the common difference? 3. A sub n equals to 3n minus 8. And we're done. Questions about arithmetic sequences? We're good? Alright, so we're going to move on to arithmetic series. What's the difference between a sequence and a series again? Series is when you take the terms of a sequence and you add them. Okay, so we're still going to be dealing with sequences, but now we're going to add the terms. Cool? Question before we go on to the next page. Okay. I want you to think this through, and this is one of the biggest problems with series. Okay? If I'm going to add the terms of a sequence, okay? So that means I'm adding every single term. So if I was looking at this, it would be like -5 plus -2 plus 1 plus 4 plus so on, right? So if I continue this forever, what would your answer be? Because the sequence goes on forever, right? So that means I'm going to have to add all the terms forever. What is your answer going to be? That's the big problem for series, right? And that's one of the things that makes this so interesting, but at the same time kind of complicated and complex for some people. They're like, wait, what? Well, think about it. Aren't these sequences going to continue to increase by, what was this, 3 every time? So that means you're adding and adding and adding bigger and bigger and bigger and bigger and bigger numbers. Where are you going to get to? Infinity. So when you add all the terms of an arithmetic sequence, you're going to get infinity. You're not going to be able to reach an actual value. So because that's going to happen for all arithmetic sequences, that means that we're not going to do series that go to infinity that are arithmetic, because they just go to infinity. That's pointless. However, can I do what is known as a partial sum, which means that instead of adding all the terms, can I say, hey, just add the first 5 terms? Will you then be able to get an actual answer? Cool. So you're going to hear the word partial sum a lot, because doing a sum of a series, arithmetic series, is just going to give you infinity. Cool? Alright, so we're going to be doing partial sums. So here we go. The sum of a finite means that it has an n, right? So that means like we're doing a partial sum of an arithmetic sequence is given by the following formula, and you're going to have to memorize that as well. S stands for sum, n means however many terms you're adding, and then obviously n again is the term, however many terms you're adding. A's of 1 you need to have a sub 1, and a sub n will depend on however many terms you are adding in this case, okay? So we're going to start with something very simple. Number 8 says, find the sum of the integers from 1 to 35. First, you have to make sure that this is arithmetic in order to use this formula. Is this arithmetic? Yes, because it's 1, 2, 3, 4, 5, 6, 7, 8, all the way to 35. So it's arithmetic. So that means that I can use the formula. So that means this is going to say S of n. Well, how many terms is there from 1 to 35? Okay, so a sub 35 is equal to, well, n is 35 over 2, right, times a sub 1. Okay, what's the first term of that sequence? 1. And what is, in this case, the last term of that sequence? 35. All right, so 35 over 2 times 36, right? You're going to have to be doing this without a calculator, so you might as well practice. Okay. What I notice is that if I divide 36 by 2, I get 18, right? Okay. 35 times 18. Well, 35 times 20 is 750 minus 70, 630. However you want to get to the answer, if you actually need to do all this by hand, do it. I don't care. If you can do it mentally, fine. Cool? But this will be on the non-calculator portion. Alright? Yes, ma'am. And it's how many numbers you use, not the actual. And this one, it happened to be the same because it was just going. But it means like literally the last term that you use. So like if it was the 20th term, you would put 20. Yes, ma'am. Cool. Number 9 gets a little bit more challenging. It's not terrible though, so I want you to think this through. It wants you to add all the 2-digit. No, so it wants you to add all the 2 digits multiples of 3. Now, there's a long way of doing this, and then there's a shortcut. However, again, this is because we're doing with sequences in your brain, you see patterns, so it's however you want to see this. Here's what this means. Okay, the long way to do this would be like, well, 3 is a multiple of 3. 6 is a multiple of 3. 9 is a multiple of 3. 12, 15, and then you list them all until you get to 3 digits and you stop, right? Because they only want the 2 digits. That's the long way of doing this, right? But then I'm going to think this through. Well, what would be the highest 2-digit multiple of 3? 99. Right? After that, I don't care about anymore because they're only asking for the 2-digit ones, right? So here's what I want you to think this through. The first, all the way till you get to 99, how many numbers would that be if you divide it by 3? 33, right? That means that there's 33 numbers starting at 3 all the way to 99. However, you only care about the ones that are 2 digits. Get rid of this one, that's 32. Get rid of this one, that's 30. Get rid of this one, that is 30. So how many multiples of 3 is there between that are 2 digits? 30. Okay, so that means S of 30 is equal to 30 over 2 times, well, what's the first one? 12 plus what's the last one? 99. S of 30 equals 15 times, well, what's 12 plus 99? 111. Okay. And 111 times 15. 1665. How did I get 30? Okay, here's the shortcut for this, okay? The highest, what is the lowest 3-digit number that you know? Yeah, the lowest 3-digit number that you know. 100, right? That means that the highest 2-digit number that you know that's an integer is 99. Okay, so I'm going to take 99, and I'm going to divide it by whatever multiple they want, right? So in this case is what? So 99 divided by 3 is 33. So that means that there's 33 numbers from starting at 1 to 99 that are multiples of 3. But I only care about the ones that are 2 digits. So I got rid of the 3, the 6, and the 9. So 33 minus 3 is 30. Cool? All right. Number 10. Find the 150th partial sum. What am I asking you to do? Find the sum of the 150 first terms. Okay? Yes, sir.
The one above,
Uh-huh.
do you only use 99 because 3 goes into it? Or do you also
Yes. Yes, I use that because 3 goes into it. So, like, if it would have been 4, what's the highest two-digit number that goes into 4? 96. Then I would use 96. Cool? All right. This means that you're adding the first 150 terms. Okay? So that means this is going to be S of 150 equals to what? Use the formula. 150 divided by 2 times, well, here's the sequence, okay? 5. 5 is your first term, right? So 5 plus, well, you need the 150th term. Do not, repeat, well, actually, do it if you like. That's going to take you the entire test. Do not try to figure out by adding until you get to the 150th term. If you do that, then, I mean, I'll have fun watching, I'll be honest. I'll be like, let's see how long it takes. I'll time it. But what do you need to do instead? You need figure out the formula, guys, in other words. Okay? You need to figure out the formula so that you can just plug in 150. Well, to figure out the formula, you know that a sub n is equal to a sub 1 plus n minus 1 times the common difference, right? Do you know the first term? 5. Do you know the common difference? 11. Can you figure out the formula now? Okay, so a sub n equals to 11n minus 6, right? So now if you need a sub 150, that's what you need, right? You're going to plug in 150. So 11 times 150 minus 6. What is it? 16 what? 1655?
Oh, minus 6.
Yes?
Oh, wait, no.
15 times 10 is 150, 165, 1654? Yep. It is 1654. Careful. All right, so it's 1654. $44. Okay, there you go. 1644. All right, so then S of 150 equals, well, 150 divided by 2 is 75, and 5 plus 1644 is 1649, and I'm not trying to do that in my head, so somebody help me out. Calculator? No, because you can do this by hand. I'm just being lazy. You can actually write this down, right? Like, what is it? 275? 675? Okay, 123,675. Cool? Alright. How we doing? Good? Alright, 11. Hey, look, sigma's back. What does that mean? What is this telling you to do? Add what? What numbers? Good. The numbers of this sequence starting where? The first term going up to the... So in other words, what partial sum are you finding? The 100th partial sum. So that means S of 100 equals 100 over 2 times, well, do you know your first term of the sequence? Well, it's not given to you, but it's very easy to find. 2. Do you know the 100th term? 200 S of 100 equals 250 times 202. Okay. Well, what's 202 times 5? 1010, right? So 1010 and just add a 0 because of the 50. And we're done. Alright, this has been a lot easier than 8.1, I hope you realize. Okay. Here's the last problem that you want to do. This is not for notes. I want you to do this one for homework. Okay? As well as there is a worksheet on the Learning Hub already that says either 8.2 or 9.2. I don't remember if I changed the numbering. But it's about 37 questions long. Some of them are very straightforward, so that's why there's so many. It's like it's either yes, no, the answer, things like that. Okay? You will have a skills check over this on Friday. It's all gonna be non-calc. No, actually, next time it's a little bit of both. Okay? All right, that's all I got for you.